One.
Right, so I'm going to go through these. I've got the high-tech camera going so that I can possibly put these on YouTube if this explanation is any good, so that you can look at it later and remember how it goes. All the high-tech there. Okay, so the first four are all similar. They're all y equals something x and something. So we should be able to draw those without doing a table of values. I'll do a table of values anyway, if I can find a pen. So, for example, y equals 3x plus 2. So if x was 5, y would be 3 times 5 is 15, plus 2 is 17. If x was 4, y would be 3 times 4 is 12, plus 2 makes 14. So we could work out values for each of those and we get something like that. And we could plot these as points on the graph and it would look something like this. A point there, so 2, 5, and so on. So if we just do it by plotting points on a graph, they could all lie in a straight line and it looks something like that. And if I can find, have we got the ruler anywhere? The big one or just that? Just do it with that then. Okay, so if we just do it by plotting points, it looks like that and it cuts at 2. But the thing about these first four is not to do it from a table of values, but to do it by recognizing the relationship between the elements of the equation and the graph. So it's got a plus 2 on the end, and that relates to the fact that it cuts at 2. So the plus number at the end is the intercept, where it cuts the axis. Skæringspunkt in Danish. And the other number, the number in front of x, that's the gradient, how steep it is, Helmingstale in Danish. And basically for every one across, this is going up by 3. And that's because the y's are going up by 3 every time here. And that's happening because every time you have an x, you multiply it by 3 and do something else to get the y. So there's a direct relationship between the number in front of the x and how steep the graph is. So given that relationship, I can then draw the others quite easily. A good graph, by the way, is labelled with its equation. So y equals 3x plus 2. It's labelled with the axes, x and y, and some kind of scale on it as well, telling you how big all the numbers are. Okay, so we'll rub that one out and we'll try and go on to the next one. So I'll rub out my table of values. I'm not going to use the table of values for the next one because I should be able to just recognize it. Okay, y equals minus 2x plus 3. So the plus 3 is telling us that it's going to cut at 3 there. And then the minus 2x tells us that the gradient is minus 2, which means that for every 1 across, it's going to go down by 2. 1 across, down by 2. 1 across, down by 2, 1 across, down by 2 over there. Okay, so again, I don't need to make a table of values as long as I know where it's going to cut and how steep it's going to be. So it's going to look something like that. It needs to be labelled with its equation. Y equals minus 2x plus 3. Okay, so plus 3 telling you it cuts at 3, minus 2 telling you how steep it is. Every 1 across is going minus 2, down by 2.
John?
Yes?
Can it go 1 across the other way, or does it have to go that way?
Well, I mean, when you're saying 1 across and so many up or down, it doesn't really matter what point you're starting at. Yeah, you could look at it. Well, you could look at it the other way, but then you're sort of saying 1 back and
Yeah, okay.
2 up. It's better to look at it in terms of left to right because you sort of think of coming from left to right as being in a positive direction, because you think of, you count. If you see counting numbers on a page, they're going from left to right, 1, 2, 3, 4, 5. So you have a sense of this way as being positive and up being positive. So it's better to think of it as up is positive and right is positive.
Okay.
Yeah. Okay, the next one. Y equals 0.5x minus 2. 0.5 is the same as a half. Let's rub this one out. Oops. Okay, so the minus 2 on the end is going to tell us where it's cutting. So that's minus 2, the intercept is minus 2, so it's going to go through the y-axis at minus 2. And then the 0.5x is telling us the steepness. So for every 1 across, it's going up by 0.5 or a half. 1 across, up by a half. 1 across, up by a half. 1 across, up by a half. Or if you prefer, 2 across, up by 1 to make it a bit quicker. But it's going to be a shallow graph, so that the gradient is, because the gradient is less than 1, it means it's going up more than it's going across, if you like. Okay, so for every 1 across, it's only going up by a half. Okay, label it, y equals 0.5x minus 2, minus 2, where it cuts, 0.5, the number in front of x, how steep it is. Okay, and then the last one of those, we've got y equals minus 0.25x minus 4. So the minus 4 on the end is telling us that it cuts there at minus 4. And then the minus 0.25 in front of the x is telling us that for every 1 across, it's going to go down by a quarter, or 0.25. Another 1 across, down by a quarter. Another 1 across, down by a quarter. Or a quick way of looking at that is to say for every 4 across, it's going to go down by 1. So I could start counting these out as 4 across, 1 down, 4 across, 1 down. I don't have to try and draw little quarter spaces on the graph. So it's a very shallow graph, so that it's not very steep, or in other words, the gradient isn't very much. It's only minus 0.25. And for all of these, if it's got a minus gradient, then it's going downhill, if you think of going from left to right. And if it's got a positive gradient, like 3, then it's going uphill, if you're coming from left to right. So just label this with its equation. Y equals minus 2.5x minus 4 for where it cuts, minus 0.25x for how steep it is, 0.25 down for every 1 across. Okay, so those are all the straight line ones. You should have been able to do those without tables of values, but it does seem like a lot of you kind of forgot the general rules for that. Important to know, very likely something somewhere on your exam will ask you to know that. Right, then the next block, the next 3 are all of the same type, really. Y equals x squared, the first one. X squared, remember, means times itself, not times 2. So 5 squared is 5 times 5, 25. 4 squared is 4 times 4, 16. 3 times 3 is 9. 2 times 2 is 4. 1 times 1 is 1. 0 times 0 is 0. And then you go into the minuses, and you've got minus 1 squared is minus 1 times minus 1. And minus times minus makes plus. So basically you're getting the same values on the other side. So minus 4 squared is minus 4 times minus 4, which makes plus 16. If you do it on your calculator like that, you might get the wrong answer. It might tell you that it's minus 16, because it will try and do the 4 squared first and then the minus after. So you might have to put a bracket around the minus 4 before you square it, and then you get the correct thing, 16. So I talked to a couple of people who were getting a minus there where it should have been a plus, because of what their calculator does. I'm going to have to think about the scale of this because this goes up to 25, so it's kind of going to go off the scale here if I leave it like that. I'm going to rescale this so that I've got 10 there and 12, and there goes the Apple TV. Just a minute. Let's see if we can get that back. No. Right, so when x is 5, y is 25. I'm still going off my graph a bit there, but I'll plot a point there. When x is 4, y is 16. Okay, so that will be there. When x is 3, y is 9, which will be there. When x is 1, no, when x is 2, y is 4, and that's there. 1, 1, 0, 0. And then it's symmetrical on the other side, so I can very quickly do this without having to refer to my table too much. And what it's supposed to, if you did all of the in-between values as well, like 0.1, 0.2, 0.3, then it should come out as a curve. Some people try and draw this and it comes out sharp. It's not supposed to be sharp, it's supposed to be kind of completely flat at the bottom. So a little bit flat at the bottom and a very smooth curve. Once you get up to the ends of it, it's almost straight. I'm going to cheat a bit and use a ruler up there. So it's, yeah, that's not very good. But it should be a very smooth looking curve. Smoother than that really, but nice and flat at the bottom. It doesn't sharply come to a point. And that kind of curve is called a parabola or parabol in Danish. And when you see satellite dishes on people's houses, they have that base, they're like that, aren't they? And they have a bit sticking out. But the shape of that dish is the same kind of curve. All of these are going to be the same kind of curve. As long as the highest power in the thing is x squared, so like x squared here, 3x squared, minus 3x squared, they're all going to have the same basic shape. It might be a bit stretched or a bit flat, but it's all the same family of curves. So that's y equals x squared. So again, if you've got something like GeoGebra installed, then it'll draw that a lot more nicely than I've done it, but you can have a go at that. Okay, so I'll try and do the next one, which is y equals 3x squared minus 2x plus 4. Okay, so that's a bit of a headache. When x is 5, so you have 25, 75, minus 10 is 65, plus 4 is 69. If you've got a spreadsheet, you can very quickly set up a formula that can solve these for you. When x is 4, so you've got 16, 48, minus 8 is 40, plus 4 is 44. When x is 3, okay, so 9, 27, minus 6 is 21, plus 4 is 25. When x is 2, so 2 squared is 4, 12 minus 4 is 8, plus 4 is 12 again. When x is 1, you get 3 minus 2 is 1, plus 4 is 5. When x is 0, then these are 0 and you just get the 4. When x is minus 1, now it starts to get tricky. When x is minus 1, you've got minus 1 times minus 1 is 1, times 3 makes 3. Minus 2 plus 4. You can get very tripped up with minuses there. 5 plus 4 is 9. Okay, 9. Is that right? wonder if I'll fluff this up somewhere. This is supposed to come out symmetrical, so I'll check this in a minute.
It's not going to be symmetrical though.
Not going to be symmetrical, so I'm worried that I probably messed one of those up. I'll figure out which one in a minute. When x is -2, -2 times -2 is 4 times 3 makes 12. Minus 4 plus 4, 16, 20. I've got a feeling it is going to be symmetrical, but about some point that's symmetrical around some point that's not one of these whole numbers, which is why it's looking a bit weird.
Actually, it's a bit symmetrical.
I got some other answers than you did.
You got
I
some
got
other
the same
numbers?
answers as on the other side.
Am I messing up with the minuses?
Let's see.
You had a problem with minuses on yours before, didn't you?
Yeah,
What I'm going
yeah,
to do is go into Excel and do this a lot more quickly. Okay, so I'm going to do this nice and big. Can you see it? Okay, so some numbers, -5, -4, hopefully it will just follow the pattern now. Yeah, and 5, and then let's put the formula in. So it's got to be that number to the power of 2 minus no, that's not right, equals 3 times that cell to the power of 2 minus 2 times that cell plus 4. 69 is what I got, and then if I just copy that formula across all of these, let's have a look. So 44, yeah, 25, 12, 5, 4, 9, 20, so I've got them right so far. 37 and 60. So if you didn't get those, then check it again. So those are right. But obviously it's quite easy to get tripped up on the minuses. When you have minuses, can get a bit tricky. So what will this look like? Well, let's rescale this. I think I'll scale this so that 1 square is 10 now. So that will be 50, and that will be 100 there, and then minus 50, minus 100. Okay, so when x is 5, y is 69, which is about there. When x is 4, y equals 44, which is about there. When x is 3, y equals 25, which is there. When x is 2, y equals 12, which is around there. When x is 1, y equals 5, which is there. When x is 0, y equals 4, which is there. And then when x is minus 1, y equals 9, which is up there. And 20, 30. It looks a bit different because it's symmetrical, not around the middle, but around some point that's here. So it bottoms out not at 0, but just slightly to the right. Where was I? 37 and 60, so something like that. But it is the same basic shape. I've just realised that 37 is 60, 30. I'll tell you what I've just realised. 10, 20, 30, 40. 50's there. So there, and 44 is there. 25, now I'm alright. Okay, so 60 is there. But it is, if you draw it on some nice graph program, you will find that it's a nice smooth curve, better drawn than I've drawn it there, and it'll look the same as the previous one. So it won't necessarily bottom out so that it's symmetrical at the axis, and it won't necessarily bottom out so that it sits on the line. That depends on the numbers in the equation. But it's the same basic shape, a parabola, as the last one. Okay, well for the next one, actually I think I'll just get Excel to do all of this for me. So I'm just going to change the formula so it's a minus there. Copy that formula across. And I'll get it to graph it for me. So I'll highlight that and see if I can remember how you do graphs, charts. I want it as a scatter graph, yeah, because I want it as x, y. So there we are. So you can see it's the same type of curve, a parabola, but in this case it's upside down, and that's because of the fact that it's minus something x squared. So the fact that it's minus something x squared makes the same shape go upside down. In fact, what I'd done, if I'd been smarter, is to do all of these on Excel. So let me just do the one that we just did with the positive value. And there you can see. So it bottoms out slightly above and to the right of the origin. I think I'll do all of the rest of these on Excel, actually, since I'm here. Now the next family of curves, y equals something divided by x. So, for example, just get rid of that. So y equals 1 divided by the number in the cell. Okay, so when x is 5, y is 0.2, because it's 1 divided by 5 is 0.2. So I can copy that formula across for most of these. What I can't do is copy it across at 0, because you can't have something divided by 0. So what you get is this discontinuous graph in two sections. Okay, so any graph that's something divided by x comes in two parts that you can't have dividing by 0, so it's got that middle bit where it's disjoint. But generally these tend to be two smooth curves. It looks a little bit odd there because of the way it's scaled it, but the general thing is two smooth curves like that. So the next one, where I do 3 divided by x, it's going to be the same basic shape, but that's what happens when I try to have something at 0 and it tries to join it up, so I've got to delete that one. Yeah, so whether it's 1 divided by x or 3 divided by x, it's the same basic shape of two curves, and it's discontinuous. And then the last one, if it's a minus something divided by x, then the effect that has is to flip the whole thing over. So it will look like that. The same sort of discontinuous thing, but flipped over when it's minus. Okay, the last couple are quite easy. It's just a question of recognizing them. I'll get that back on. Right. Y equals 4. So you've got your x-axis and your y-axis still. And it's just all the points where y is 4. So let's say we've got 1, 2, 3, 4 there. It's any point where the y-coordinate is 4. So like you've got 0, 4 there, you've got 5, 4 there, and always here the y-coordinate is 4. It's all the points where the y-coordinate is 4. If you think of it in terms of y equals something x plus something, like the first ones, then it's y equals 0x plus 4. So it cuts at 4, and then the gradient is 0, so it's a flat line that doesn't have any steepness. Then the next one, y equals x, so it's just all the points where the y-coordinate is the same as the x-coordinate. So 4, 4, 3, 3, 2, 2, 1, 1, 0, 0, minus 1, minus 1, minus 2, minus 2, minus 3, minus 3. Whatever x is, y is the same. And again you can think of it in terms of the first group, with the gradient and the intercept. That's like saying y equals x is like saying y equals 1x plus nothing. So it cuts at 0, and the gradient is 1, meaning that for every 1 across it goes up by 1. Okay, and the last one, x is 4. It's a bit like the one that said y equals 4. Wasn't it x equals?
No.
Was it?
No.
Was it 2 before? Apparently not. Anyway, it doesn't matter.
Yeah, it was 2 before.
Oh, well, we should be 2, but...
Better get it right.
But it's basically all the points where the x-coordinate is 2. So it's basically a vertical line. So here the coordinate is 2, 0. Here the coordinate is 2, 4. Down here the coordinate is 2, minus 5. It's anywhere where the x-coordinate is 2. So it's just a straight line going through. And they sometimes ask these weird ones on the exam where it's just a straight line one way or another. Okay, that's it for today. If that's recorded, I'll put it on YouTube and give you